Hello, everyone. Today, we will discuss Chapter 5, Smart Contracts. This chapter primarily covers an introduction to smart contracts, the development of smart contracts, the challenges and advancements in smart contract research, as well as the future trends and outlook of smart contracts. Let's start by understanding smart contract. First, let's clarify what a smart contract is. As another core technology of blockchain, smart contracts possess characteristics such as decentralization, trustlessness, programmability, and immutability. They can be flexibly integrated with various data and assets, facilitating secure and efficient information exchange, value transfer, and asset management. So what exactly is a smart contract? Let's illustrate with an example. Mahjong, one of the common leisure activities, operates similarly to the concept of smart contracts. In a Mahjong game, the four players can be abstracted as the four nodes in a blockchain, where they all hold equal standing. They collectively agree on a set of rules. First, the cards drawn by each player are known only to themselves, and the other players can only see the hash values of the 13 cards. When a player discards a card, it is publicly revealed, and the discarded card is displayed for others to see. No one can modify a card that has already been discarded. Finally, whoever first completes a hand that meets the winning conditions, such as 4 straights and 1 pair, will automatically win the game according to the established rules. At the same time, the round will end automatically. This rule is an embodiment of a smart contract, and it runs automatically, vividly demonstrating the function of a smart contract. Let's consider a more specific example. For instance, in the past, when electronic contracts were not as popular, we were still in the era of paper contracts, and a typical example of traditional contracts would be a housing lease agreement. With the advent of Smart Contracts 1.0, a common example would be an automatic beverage vending machine, which is an embodiment of Smart Contracts 1.0. Then, with Smart Contracts 2.0, the main case is platforms like Ethereum, which have deeply integrated smart contract technology, marking the era we are in today. In the upcoming Smart Contracts 3.0, we will see the introduction of smart and automated social applications. So, in Smart Contracts 1.0, the concept of smart contracts was proposed by Nick Szabo in 1994. Smart contracts were first defined as a set of promises specified in digital form, including agreements that the parties involved can execute on these promises. The previously mentioned vending machines and point-of-sale intelligence management systems can be seen as early applications of smart contracts. In Smart Contracts 2.0, a typical representative would be Bitcoin, a peer-to-peer digital currency proposed by Satoshi Nakamoto in 2008, which enables trustless transactions. In 2013, Vitalik Buterin launched Ethereum, an advanced smart contract and decentralized application platform, officially introducing smart contracts to blockchain technology. Thus, in Smart Contracts 3.0, it has been redefined as a computer transaction protocol that automatically executes contract terms without the need for intermediaries, stored on the blockchain. In Bitcoin, smart contracts are implemented in the form of Bitcoin scripts. This was an early application of smart contracts in blockchain, but due to the limited computational power of scripts, it could not implement complex logical structures. The Ethereum platform, inspired by Bitcoin's technology, extended the scope of applications. This platform is similar to the Apple App Store, involving a wide range of applications such as economics and social interactions. Users can quickly develop a variety of smart contracts, including cryptocurrencies, based on their own needs and preferences. Currently, more and more blockchain platforms are emerging. The life cycle of a smart contract can be summarized into 6 stages based on its operational mechanism: negotiation, development, deployment, operation and maintenance, learning, and self-destruction. The infrastructure model of a smart contract is structured from bottom to top as follows: infrastructure layer, contract layer, operation and maintenance layer, intelligence layer, presentation layer, and application layer. Let's first understand the infrastructure layer. This layer encapsulates the basic blockchain infrastructure, such as the distributed ledger, consensus mechanism, and development environment, providing a trusted execution environment for contract execution and other operations. The key technologies of blockchain infrastructure, such as P2P communication networks, consensus mechanisms, and incentive mechanisms, are used to complete the operation and add the execution results to the distributed ledger maintained by each node. The operating environment involves the development, deployment, and invocation of smart contracts, which requires a variety of dedicated development tools, including programming languages, integrated development environments, development frameworks, clients, and wallets. Oracles are used because smart contracts typically run in isolated environments. Oracles provide trusted external data sources to query the state of the outside world. Next, let's look at the contract layer. The contract layer primarily encapsulates the static data of the contract, including the contract text agreed upon by the parties, the contract code, and the interaction protocols between contracts. The smart contract static database encapsulates all the resources required for contract invocation, execution, and communication. The content of the contract is in the order of the smart contract lifecycle. The parties involved first agree on the contract content. Contract code is created by developers using algorithms and software engineering techniques to encode the contract content into blockchain-compatible if-then statements or what-if scenario-based rules. The intelligence layer encapsulates various intelligent algorithms, including perception, reasoning, learning, and decision-making, adding intelligence to the smart contract built in the previous 3 layers. In the future, smart contracts will not only automatically execute based on predefined if statements, but also carry out what-if intelligent reasoning, computational experiments, and autonomous decision-making in unknown scenarios. In blockchain, transactions output to a specific contract address to trigger a smart contract. Smart contracts facilitate functions such as receiving, storing, and sending data, as well as managing smart assets on the blockchain. Depending on the programming language or operating environment, smart contracts can be categorized into script-based, Turing-complete, and verifiable contract types. Now, let's analyze a key feature of smart contracts. Smart contracts possess several technical characteristics: trustlessness, automation, immutability, and traceability. Trustlessness means that all contract terms and execution processes are transparent and public for all users on the blockchain. Automation means that once a smart contract is successfully deployed on the blockchain, it takes effect immediately and automatically executes when triggered by the specified conditions. Immutability means that once data is stored on the blockchain, it cannot be altered. Traceability means that through the use of blockchain technologies such as digital signatures and timestamps, the history of operations on the blockchain can be queried, ensuring its traceability. Everyone, that concludes the content of Section 1 of Chapter 5.